Hello, everybody. It is a pleasure and an honor to be presenting today. First of all, we'd like to thank our organizers for this very important and very interesting event. If I may introduce myself, I'm Peter Stavroulakis. I'm an assistant professor at the Department of Maritime Studies at the University of Piraeus, and today we're going to be presenting our work with two of my colleagues, Ms. Maritina Kyriakopoulou and Mr. Periklis Prousaloglu. Our domain basically refers to shipping. So in any type of book, textbook, magazine, journal, whatever we open up with reference to shipping, one of the first things that we're gonna come across is the fact that shipping is very important, of course. That's common knowledge. We're also going to be able to very easily access the amount of trade that utilizes shipping each year, which is a very huge percentage. So we need shipping for almost everything that we require in our everyday lives. But at the same time, because traditionally, not only in the shipping industry, but in most of our industries, the focus is on profit maximization and accounting cost minimization. We see, as in other industries as well, we see that in shipping also, that we are able to generate profits, but at the expense of society, essentially. So at the same time, whilst generating profits, we're also generating an array of external costs for society, albeit the environment, ourselves, future generations, ecosystems, along with social costs as well. We have many very well-known and well-documented cases of slavery, of exclusion, of sexism, discrimination. So there's a lot that we need to do within the industry in order for us to venture towards sustainability. So most of the topics that we've mentioned, we'll see a lot of research generated within the body of knowledge, but what we haven't seen until now is a holistic encapsulation of all of the issues that are underpinned with reference to shipping. So this was essentially our research gap and uh, the relevant goal of our research as well. So today we're very happy to be presenting our first step towards this direction. We've used artificial intelligence, and we've used a couple of more instruments that we're going to be introducing and talking about today in order to provide a holistic framework and inventory with respect to the external costs of shipping and how these can be minimized. And we are talking about the whole life cycle of the vessel from its birth, uh, from shipbuilding up until its scrapping. So without further ado, I'm going to pass the floor to my very good colleague, Mr. Bursalulu, who will continue our presentation. Thank you.
Good morning, everyone, from my side as well. And thank you, Peter, for the introduction. As Peter already mentioned, today we're going to present our research titled The Ethical Footprint of Shipping Pollution. Shipping, as we know, is vital for the global trade, accounting for approximately 90% of the cargo transport. However, despite its economic importance, the industry significantly contributes to environmental externalities, including 3% of the global greenhouse gas emissions. These externalities arise throughout a vessel life cycle, from the construction to the operation, and then to the decommissioning and scrapping. Addressing these external costs comprehensively requires a structured life cycle-based approach. Next slide. Yeah, our study introduces a clear practical life cycle methodological framework utilizing the life cycle assessment to evaluate the shipping externalities comprehensively. Importantly, we utilized the artificial intelligence and more specifically the ChatGPT model of 4.5 as a tool to enhance the robustness and adaptability of our methodological framework. Now, our main objectives is to provide stakeholders, researchers, policymakers, and industry professionals with a clear and practical method for evaluating environmental externalities effectively. The framework covers distinct life cycle stages, shipbuilding, operational phase, and the decommissioning phase. At each stage, we first clearly defined the scope and boundaries, and then conduct an systematic data collection. Now, our life cycle assessment comprises of 5 detailed steps. First one is the scope, definition, and boundaries, establishing the life cycle stages to assess construction, operation, and decommissioning, the geographic scope, relevant impact categories, and the type of the ships that is evaluated. The second one is the data collection, gathering detailed information on materials, energy consumption, operational profiles, emission factors, fuel types, and ship scrapping procedures from diverse and reliable sources. The third one is the emission quantification, utilizing robust calculation methods and the life cycle assessment, inventory basically assessment, to determine the exact quantities of the pollutants emitted during each life cycle stage, ranging from the CO2 emissions to particulate matter and to hazardous waste. The fourth one, which is the monetization, applying well-established valuation methods such as the social costs of carbon, pollutant-specific damage factors, and cost estimates from authoritative studies and the regulatory standards to translate the emissions into economic terms. And the fifth one is the aggregation and interpretation of the results, basically combining and analyzing these results to pinpoint critical environmental impacts and potential areas for improvement. Results are normalized per unit of cargo or per voyage, facilitating straightforward comparisons across different scenarios, vessel types, and regions. And now Martina will continue with the analysis of each distinct stage of the framework.
Thank you, Pericles. So to better understand the concept of the framework, let's have a quick look at the externalities of each stage of a vessel's life cycle, and beginning with shipbuilding, which is an energy and labor-intensive industry. A significant number of emissions is generated during the construction of a vessel, mainly from the welding of heavy materials and metals and the usage of shipyard machineries. The emissions generated in the shipbuilding stage are often overlooked when we refer to shipping pollution, even though they possess a significant threat for the environment, releasing thousands of air pollutants into the atmosphere. The hidden costs of those externalities can be minimized by adopting greener materials and technologies in shipyards during the constructions and maintenance of the ships. When we talk about shipping pollution, most of the times we refer to the emissions produced from vessels' operations, and indeed a significant percentage of shipping externalities derives from the daily operating activities of vessels. Fuel consumption is nowadays the most concerning issue that the industry faces, as the burning of fossil fuels produce tons of carbon dioxide, and other harmful pollutants such as sulfur, nitrogen oxides, and particulate matter. These pollutants have well-documented external costs on public health and the environment. An interesting example showcasing the operational externalities of vessels comes from a case study that took place in Greece and focused on the annual emissions from all cruise and ferry activities in the island of Crete. The finding was that the yearly external costs were equivalent to 25 to 35% of the shipping company's revenue from those operations, and if these companies had to pay for the pollution they caused, either their profits would significantly drop or ticket prices would need to rise accordingly. Vessels under operation also encompass several external impacts, such as the generation of underwater noise that has been linked to behavioral changes and stress in whales and dolphins, and also poor practices such as daily waste dumping, oil spills, and accidents can have severe consequences for the marine ecosystem. And finally, scrapping is the last stage of the ship's life cycle and is an extremely dangerous and pollutant procedure, both for the environment and human health. Ships are often being scrapped in developing countries as the scrapping prices are low, and for instance, in South Asia, like India, Bangladesh, and Pakistan, that are also referred to as toxic hotspots. The method of beaching is a cost-saving option for shipping companies, but as the process is being done manually, it is performed at the expense of shipbreaking worker safety and environmental prosperity, since hazardous substances are often dumped directly into the sea. From an economic perspective, the profits derived from shipbreaking are gradually increasing, but this ship option disregards the severe externalities it provokes to human health and the environment, and it is also interesting that the environmental impact of scrapping varies according to the process used and the ship's materials. And finally, this table summarizes the categories that should be taken into consideration when we develop the assessment framework to better manage the externalities of the decommissioning stage.
So, in conclusion, our research proposes a holistic, transparent, and actionable framework for evaluating the externalities of maritime operations across all life cycle stages. By accurately identifying and monetizing these costs, maritime practitioners can adopt effective mitigation strategies, significantly reducing the environmental footprint at every stage and at every life cycle stage. Our goal is to foster basically ethically driven and sustainable shipping practices, aligning well-known industry operations with environmental prosperity and economic development. Now, the next crucial step will be the practical application of this framework, making it integral to the industry's sustainability goals. So we'd like to thank you very much for your attention, and we are looking forward to any questions or feedback that you have. Thank you.
Thank you very much. Thank you.
Thank you.
Bye.